Okay, so how does this then relate to gravity?
Okay, now Newton, please place the marble on the fabric. Now I'm going to place this medium-sized metal ball here. What do you observe?
I see two objects moving towards each other at a certain speed.
That's correct. Now what you see in terms of the objects moving towards each other is what we see as the effects of gravity. If there was no then, and the fabric of space and time was totally flat, then these two objects will not move towards each other. It is because massive objects bend space-time and cause it to curve that we see objects now moving towards each other. That is gravity. Now, let's repeat this again with a larger metal ball. Okay. So I will place this marble here. Okay. And you will place.
And I will place this larger metal ball here.
Okay, let's see that again. Alright? So I will place this marble here.
And I'll place this here.
So what do you observe now?
It seems that the two objects are moving faster towards each other.
Well, precisely. And this is what your law of universal gravitation explains. That is, the larger the two objects are, the stronger the gravitational force between them, and we see this as the speed at which the two massive objects are moving towards each other.
Now I understand why you said the theory explains what gravity is and how it works.
In fact, I can explain the second part of your law too. So let me replace this metal object with an even more massive object to demonstrate. Now, what do you see?
The dent is so much deeper.
Well, it's more than that. You see, as you get closer to the massive object, the slope of the dent gets steeper and steeper. The nearer the object is to the massive object, the steeper is the slope, and the faster the objects move towards each other. Now, this confirms your law that as objects get closer to each other, the gravitational force gets larger and larger.
Wow, that is amazing! How you can now visualize what causes gravity and how my law of universal gravitation now actually works.
Well, glad to be of help, Newton.
So, I hope that you can now relate the bending of space-time with the effect of gravity. Einstein's theory of general relativity says that massive objects bend space-time. This bending has a consequence to what we see as the effect of gravity. If massive objects did not bend space-time, objects do not move towards each other. But because massive objects bend space-time, objects then move towards each other, and we see this effect as gravity. The more massive the objects are, the larger the bending, and we see that the speed at which the objects moved towards each other increases. That means that the effect of gravity increases when the objects are more massive. Also, the slope of the bend is actually not constant. As we move closer and closer to the massive object, we can see that the slope increases with ever-increasing gradient. Hence, objects actually gain speed in our experiment as they near the massive objects because the slope is getting steeper and steeper. This is as described by Newton's law of universal gravitation, that the force of gravity increases as objects get closer to each other. So, we hope that you have found this visualization of the bending of space-time and how it relates to gravity useful in your understanding of the effect of gravity. Watch out for our next video on the movement of celestial objects around a more massive object such as the Sun and how we can visualize this easily in our experiment. Please like, share and subscribe to our channel and click the bell so you will not miss our upcoming videos. Thank you.